Okay, I think I'll start the lecture now. So welcome to CS264. This is lecture 5. We're in week 3 already, and that's moving very, very quickly. So we're going to talk about software design, and today we're going to look at revisiting object-oriented concepts. This time we're going to be using C#. I see a mistake in the first page, so let's just fix that. It is actually lecture 5. Okay, so we're in lecture 5. So my plan then is to look at revising some of the fundamentals that we would have in object-oriented design using C#. So the plan for this particular lecture then is to go ahead and review some of the things that we've seen already with object-oriented fundamentals, and that was mostly in first year for many of you, and then to try to tie it in with the C# stuff that we've been looking at recently. Now, to be honest, what I've been doing really is I've been trying not to make too much of a big deal around, the object-oriented aspect to this. I've been working with classes, I've been working with methods, instance variables, class members, and I haven't really told you explicitly about these. I just use them and hope that by using them and seeing them being used, that this will help with understanding the context a little bit. Because you do, your experience, you're third year students, and you do know how to develop with OOP. You may have forgotten some of it, I've forgotten some of the fundamentals, but I think you know how to use them. And really, I suppose from my perspective, this is because I tend to use an approach to teaching OOP called objects first. So I think when you did object-oriented programming with Java, you did objects late or object second, if you like. So, you were taught a lot about the imperative and declarative structures of programming in that form, and then you introduced objects afterwards as kind of wrappers, and you were told, don't worry about all of this, this public static void main thing, So, I don't like doing it like that. I like to start with objects and work around that and think about modeling the world as this collection of interacting objects. So, so that's why I kind of use it as a norm, and maybe it's right, maybe it's wrong, but the jury's out as to which is better. But believe me, people who teach computer science like to think about this kind of stuff. So let's move ahead then and go back and have a look at some of those concepts that we did see in first year. And I'm sure you know them already, but it's a good idea at least to have them here again. Okay, so object-oriented programming then has a bunch of concepts around it, and really it is a conceptual approach to design and developing software. So it's what's called a programming paradigm. So where the applications, and these are just your programs, they're organized around interacting objects that are derived from classes. You know this, but it's a good idea for me to tell you a little bit about it more formally. So I think it's not bad really to go over this stuff again. So we mentioned classes there. So classes are templates for objects, and objects are instances of classes. And this is the language that we would use. So at their core, objects have attributes, okay, and these describe the features of the object, and objects also have methods then, and they provide an interface for interacting with the objects. So a lot of the time we would just create these without really thinking about it being an interface per se. And you will have seen this in Java, of course. You could say that here's class A, implements interface B, for example. So we can think about that, and you know about that already. So if you think about, for example, a lamp object, some real-world lamp, that would be an instance of a generalized lamp class that has a state, and the state might be some kind of attributes that would be there. And then you might have two individual states then that could be on or off. And then the interface could be just a toggle, which would be a switch that changes the lamp state with every interaction. And depending on the kind of lamp, it could be a strobe lamp, it could be, a dimmer lamp, and so forth. The functionality of switch really would be different depending on each one. Okay. So we can see then that an object's instantiations are able to use their interface methods to change the state or the field's attributes or values, and it's just like sending an object a message. And so object-oriented development is a lot about, creating classes, deriving objects that use those classes, and then the executing program tends to be about the message passing between the various objects. Okay. So some more concepts then. So when we tend to encounter these terms, when we read about objects and classes. Then we have class variables. We've seen this before, and these belong to the class. There's only one copy of each variable. Okay. There's an instance variable. So that's an individual object data. So every object has its own copy of this particular variable. And then the member variables, which is a term that we use to refer to both the classes and the instance variables simultaneously. So we tend to use the same terms when we're referring to methods. We have class and instance methods as well. Object instantiation, okay, is a key term, really, and that involves calling a special method that's referred to as a constructor. Okay, and constructors can have parameters, and the parameters they facilitate instantiation or initialization, at instantiation, and it's a form of customization. So individual objects that are created can have very specific states or the structure will be the same, but the values associated with that structure can be set using the parameters. So parameterized constructors can be overloaded. Okay, that's a term that you may remember as well from your Java development. So that means that the class has many constructor methods, and I mean essentially those constructors are all of the same name, and it means that the overloading means that you will have one with two sets of different parameter types. So for example, you could have a lamp that might have not necessarily a lamp, but you could have a class that would have some variables, two variables, and you could just have a default constructor that sets some default setting, but you might have an additional constructor with two parameters, A and B, for example, that sets those parameters. So it's fairly straightforward, and it's not uncommon for you to be able to do this anyway. So I guess what's interesting here is that there are four core concepts that are core principles that are associated with object-oriented development. And the first is encapsulation. Okay, so there's encapsulation, abstraction, and there's inheritance and polymorphism. So let's look at these in no particular order. Well, some order, I suppose. Encapsulation is the first thing. So everything that you've been heard about up until this point about wrapping, class members up in a class and then being able to use that to instantiate objects. That's all about encapsulation. So the implementation details, the state of the object, they're all privately held inside this defined wrapper or the class. And other objects don't have access to this class or actually have the authority to make changes to the state of that class. They're only able to call the object, create the object, or the class via an interface. And that interface is just this list of publicly available methods. So that approach to data hiding inside the class provides an enhanced code security, and it also avoids unintended data corruption. So it's a nice way to set and package these things. So abstraction is our second core concept. So that means that objects only reveal the internal mechanisms that are relevant for the use of other objects. So hiding any of the unnecessary implementation or source code. This approach aids developers and consumers more easily make changes and additions over time. It's a simplified approach, and it's very, very efficient. So you can hide stuff in here inside your classes and the result of that. So the final two really are inheritance and polymorphism. So the relationships and class hierarchies really, in other words, that's what inheritance is all about. So in other words, that you have subclasses between objects and can be assigned. So, what this does is allows developers to reuse shared code or logic while still maintaining this unique hierarchy. And that's a key principle of object-oriented programming, OOP. And it requires thorough data modeling. And in fact, that's why we're doing this particular module in software design, because the software design is about, given these principles of OOP, how do we combine them in order to be able to make really good and powerful and well-designed and excellent programs, and programs that work as well, of course. But remind you, that's another day's work. Okay, so it certainly reduces the development time and errors, and the classes inherit class members if they're permitted to do so as well, and that's an accessibility issue which we'll come to a little bit later. So that's an important thing about inheritance, really. And it's nice as well if you're developing something as a group or in a team. Then you know what you can do is set up your interface, and it's a bit like you did when you were set up creating an API for some REST application. So you define the interface and then you implement the method. So as far as the end user of the consumer of that particular API is concerned, then they don't know how it works. They just know how to access it and be able to use the functionality. And it's the same thing with classes and subclasses. You might have one group of developers who are working on the parent classes, and then it's up to the individual subclass developers to implement, the functionality that will be required, for example. So it's really a nice way to separate and delineate between the work associated with the various parts of your application. Our final concept is this polymorphism. And polymorphism is really nice, and it's core to OOP, and it means that objects can take on more than one form. Okay, like they might have different sets of methods, for example. And that form depends on the usage context. So the program will determine which meaning or which usage is necessary for each specific execution of that particular object. And that reduces code duplication. So, you probably have the same method set, but how it will work differently for each one. I always give this example when I'm talking about OOP, that I remember flying to Austria at one point, and somebody came to me and asked me, are you a doctor or something? And there's somebody sick, and we need a doctor. And it was really interesting. Just because doctor was on my ticket or something, And I said, no, I'm not a doctor. I'm not a medical doctor. But the man sitting across from me said, I'm a surgeon. I can work in place as a doctor. And it was really interesting because, from a polymorphism perspective, so we had set up this hierarchy of the difference between surgeons and doctors, and basically, he was more specialized, and sometimes subclasses are more specialized classes, really, than the parent classes, or these derived classes are more specialized than the base classes, and, but it meant that, even though he was more specialized, he was still able to use all of the base things that happened. So the person was fine. I mean, he did a great job. But, that was polymorphism in action, so you're essentially casting to the role that you need to be at a particular time. And this happens with classes and objects and object hierarchies all the time. So it's a useful thing to try and understand. If you get polymorphism, you'll really get OOP. And the model, and I mean, we talk about this, and I'm not so sure whether you get told this a lot of the time when you're developing new things. I mean, we were often critical of JavaScript when we worked on this last year. But, OOP, people are very critical of OOP, I mean, their criticism is really, really important. And you have to look at, is this the best way to do this? And does it work? Is it good? And what are the issues and caveats associated with doing this? So it has been criticized by developers for many reasons, and you should know about the issues. And you should know about it before you select any development language. So you have to look at this then in context, how we go about programming. So the first one is that, and very popular now, is functional programming. And that functional programming approach focuses on the evaluation of expressions rather than the execution of the commands, essentially. We have structured programming, for example, and there are in other words, this is the three ways in which we solve problems. Okay, sequencing, selection, and iteration. We did this in first year, and they're sufficient and these three are sufficient to be able to express any computable function. And there are theorems that allow you to prove this and so forth. And then there's imperative programming, and it focuses on how a program operates. So you'll see declarative, you'll see all sorts of things. So JavaScript, I love JavaScript as well, but JavaScript is really nice because JavaScript allows us to be able to do functional, structured, imperative, whatever form you like, in addition to OOP as well, this object-oriented programming. So I like it a lot because of that. But anyway, back to C# or back to OOP here. So the developer's largest concern is that OOP overemphasizes the data component of the software development. It doesn't focus enough on the computational algorithms. My personal response to that is, you can work on all that stuff within the methods and do a good job within the methods. You don't ignore all that good second-year computer science stuff that you would have done just because you're doing OOP. It's where it happens and where the algorithm happens as well. They also say that OO doesn't effectively handle concurrency, and that's cool because and I agree. And when we start working at OOP, which was developed around that programming language called Smalltalk originally, we didn't really have that multiprocessor computation that we have now. Now we have it a long time. I remember doing work on microprocessors, multiprocessing, and we didn't use OOP at all either. But that's a valid criticism. OOP may also be more complicated to write, and it can take longer to compile. That's fair enough. I agree with that. What I would do though is really to get you thinking about that. There's a great article worth reading, and it's called by David Casall. And it's Why Are So Many Developers Hating on Object-Oriented Programming? It's a 2009 article. And really, I guess, he gives you a kind of history, a modern history, very short modern history, by the way, of, the problems with OOP, and really, I think a lot of the problems are people who are advocates of functional programming, and they just want to say, let's hate OOP. But look, we're going to use it in this particular module. I'm not too worried about this. So it's we always have to take these criticisms where we can. Okay, so one thing as well, if you want to know about OOP, then there are lots of nice resources, lots of books. You can look up any book and it'll tell you. But one of my favorite all-time articles recently is a brilliant article on Free Code Camp. And it's a great site. It's worth visiting. And it's called How to Explain Object-Oriented Programming Concepts to a 6-Year-Old, and it's by Alexander Petkov, and it's a 2018 article. Now don't be put off by the fact that a 6-year-old. 6-year-olds are really tough. They're really tough to try to get stuff. They ask really hard questions. So, but this article is accurate. It's insightful. It's not in any way patronizing. And I certainly don't. I'm not recommending it to you because I would consider you to have 6-year-olds. But what's happening and what's really important to that is that you may be in a situation where you have to quickly and accurately and succinctly explain your understanding of OOP. So, for example, you might be in an interview situation where you're looking for a placement interview and so forth. You really have to demonstrate in the fundamental and key terms, what is actually happening if you're asked about the OOP in a technical interview. So, and that's really important. So really what happens is that you have to go beyond the copy and paste. I know a lot of you will look at the demo programs that I use and did last year as well and copy and paste them and make modifications. But some people, I can tell from the examinations, people don't actually understand what's going on. For interviews, you have to be able to understand what's happening and go beyond all that. So you have to understand the concepts. This is a brilliant article to look at this. So, and really, I suppose the takeaway from this particular article is that, you need to be able to take an example that you actually understand and then develop it for explanation so that if you're asked about it, you'll be able to talk about it in a way that's accurate, in a way that's insightful, and a way that's succinct. Okay, so for example, here's a nice description of this here. It's always good when you see cats appearing in technical articles. And so here we have a cat class and, a whole bunch of methods and so forth. And we have a description of this. This is one of the diagrams taken from the article. And I really like it. It's a wonderful article and I'd certainly recommend you read it. The link is there. You can click through and get that link. Okay, so let's think about access modifiers. Actually, we can take a break just there before we move on to that. So we've kind of looked at some of the core things now. Do any of you have any questions? The YouTube chat is available there, and you can post questions if you've got anything you'd like to ask me about this so far. Okay, that's good. Thanks, Brian, for coming back to me. Okay, so we're in good shape there. Okay, right. So now we're going to talk about access modifiers. We have seen these. We've seen these before. Okay, and we use them. But in some respects, you need to get an overview of all aspects of this. Okay, so. Access modifiers, okay? So they help implement the core principles of OOP that we've discussed already. So what they actually do is they set the visibility of the class members. And there are 4 core access modifiers in C#. Public, protected, private, and internal. Now you would have seen some of these public and protected, of course, already with your Java. So there are also two combination access modifiers, one called protected internal and one called private protected. Okay, so the public members can be accessed anywhere. The protected members can be accessed only within the class itself and by inherited and parent classes. The private members are limited to the containing type, only within the class or the interface. The internal members may be accessed from within the same assembly. And that notion of an assembly might be different from Java. So what's happening here is that the assembly refers to the .exe file that you would have created, or the DLL, the dynamic linked library that will be generated. And you've certainly seen the DLLs when you've been executing your .NET programs within the terminal. And you'll see that when you compile, it does a build and it creates these libraries for you. And it also has seen these when we're accessing external libraries. And we can distribute and package DLLs or code as DLLs. Somebody sent me an email recently asking how to create a .exe from your .NET software, from your program. So I sent the link, but if anybody else wants to do that, just give me a shout and I'll be able to let you know as well. Okay, so that means you can produce this distributable piece of code that will run under Windows, So, you might want to take the exercise that you're doing for your assignment, for converting the tables or something else, and then just make an exe that you can just distribute rather than showing how you did the work, So it's kind of an assembly there, okay? Finally, the last two, the protected internal class members, that can be accessed by any code in the assembly in which it's declared, or from within a derived class in another assembly, okay? And the private protected class member can be accessed only within its declaring assembly, by code in the same class or in a type that's derived from that class. Okay, these are hard. These are hard to remember, all of these, and unless you have a real context, for working in development, you're not really going to know, get it all. Okay, so here's a really nice table for C#, the object-oriented programming guide. From Zcode, it's a 2020 article, so it's fairly up to date. And this gives you an overview of the actual classes. So we can see the protected, public, internal, private, protected, internal, private, protected. And here are the various organizational structures that you might have. A class, the current assembly, derived types, these are subclasses, derived types in the current assembly, an entire program. And this could be so, and the plus means that they're visible, the member is visible, and the O means it's not visible. Okay, so it's a nice table. It's definitely worthwhile having a look at and using, and it would be with prime and practice and context and examples, you'll figure out how to do all of this. Okay, so what I want to do for the second half of this particular lecture is to look at some of those four encapsulation, those four, I'm reading the slide here. I'll first talk about the piece of code, and then we'll head on over to VS Code and we'll run and make some changes and see how it works and that is going. So again, if you have any questions, you can just ask. If you need to see changes, then we can make that work as well. Okay. So encapsulation is a very simple thing. You have been doing this for the last 3 weeks, or last 2 weeks, or however long it's been. We've been here already. Okay, so basically, every time you've been writing a program, and you've been wrapping and creating instances of variables inside that class or that program class, you've been doing encapsulation, really. These are simple C classes, C# classes. They have different kinds of class members. They have instance variables, methods, and properties. And that was something, this notion of properties is something I discussed recently in one of my lessons. Okay, so when you did your Java, or at least some of the normal way that you would teach Java, you create your class. And then when you have your class, you have your variables, which, the general rule is let's make those instance variables private, okay? And then create some public getter and setter methods that we use to be able to work and access those. So it means it hides and it encapsulates all of the content, all of the data inside that object. You don't know how it's internally structured really the interface you have are these getter and setter methods. So you sometimes, if you had a variable called x, you would say you create a setter method called getX or setX, and one would be, and these may be overloaded and so forth as well. So it all depends. So we have something similar going on here, and initially I was using, by way of just simple examples, I was always just creating publicly accessible instance variables, and then we were accessing them using the dot notation from the objects that were created from those classes and so forth. Sometimes I would have set methods and so forth. And then in one of the lessons I showed you a little bit about using properties. So we'll see that again here. So again, this whole thing in terms of encapsulation is all about using the public and private in context here. So this program is called myaccess.cs, and again you'll be able to find it in the demo zip file, which I will upload later in the week. Okay, so here we have a class called person, has a public string called name and a private int called age. And let's ignore the code here for a minute with the pink block. And again, we have an int get age, and that returns this .age. So this instance age, and use of this keyword should be familiar to you from your Java, of course, and in JavaScript, of course. And then we have a method that sets the age as well. So we have this getter and setter for the age, but we don't need one really for the public, for the name, because it's been public anyway, and age is private, so we can't get at it. Okay. So an alternative approach to doing this public string name would be actually to set up a name property. So what we do is we create a private string name, and we didn't have to call it a name, we could call it anything, but it's good practice to use a lowercase letters for the private instance variable, and then the property will have an uppercase letter. And so we can see this association between this property and this field or instance variable. And then we set up the get and set methods here associated with that for the property. So when this is used in a get context or in a set context, we're able to work with those. But these are public. Okay? So these are public because this is public. Okay, so let's head on over to VS Code and see if we can get this one working. Okay, here we are with VS Code and this particular application. Okay, so again, this one is called myaccess. We have the person string. We're able to make it work here. It's no different than we had it. So essentially getter and setters. But really what's going on here is that we create a new person from this person class, and we're able to access the name, give it the name Joe Bloggs, and we're able to set the age, and then we're able to write Joe Bloggs is whatever, 40 years of age. So let's have a look at the terminal, and we'll execute this. And it should run as we expect. Okay, let's change it now to use the property. Okay, get rid of this, get rid of this. Oh, let's get rid of it this way, because this is a nicer way to get rid of blocks of code. So we come with the block, and then we'll have to get rid of this one, because we've already changed the name, because previously here we'd made a public string for name, and then we want to make a private string for the name. Okay, and then we're creating this property which is a public. Okay, and then we have a getter and setter. We have our getter and setter methods just here. Okay, and this hasn't changed, this hasn't changed, and we've got an issue. Look, see, we can't really access name because name is invisible to us. So let's try run. We know it'll give us an error. Okay. No, I have to save this one up here first, of course. Okay, and we get that name because a person.name is inaccessible, and that's what we would expect. Of course, unsurprisingly, that's why we have this line here, which access the property. So let's take this one and now access the property, because we can't access the internal structure. That's down to encapsulation. Let's save this, Do the run thing again. Oh, why did I not? Person.name is inaccessible. I thought I had that out. Let me save this. Ah, of course, this one here. I had this line as well, so that's why we couldn't do it. Okay, nice one. Okay, and you know, it works this time. So I guess really what I wanted to do is to get you thinking about encapsulation and the ways we might try to do some encapsulation. So I think that's useful. It's useful because we also see that we have two ways of thinking about how we might want to do the encapsulation: gather and set our methods in that traditional way, or to set up some properties. It's up to you, whichever way you want to write your programs to do this. Okay, let's move on to inheritance. Sorry, but actually before we go to inheritance, do any of you have any questions about the code that was generated already, you know, for the inheritance one? I mean, you've seen this before, but I mean, any questions or issues around that? Do you want me to make any changes at all? I can do this. Anything here? No? And I know there's a slight delay. Okay, good. Let's progress then if we want to see this. Okay, thank you. Okay, so the next one is inheritance, and I guess this is the bit that's really, we haven't done too much of this. I did a little bit. I referred to it with some shapes in some of my lessons earlier, but we can think about this inheritance then. Okay, again, it's a simple C# class, and that inherits different kinds of class members. So it inherits instance variables, methods, and properties from some parent class. So again, this particular example uses public, protected, and private. So the program is in a file online called myderived.cs, and we can find it in the demo. So we'll open that in a few minutes again. Okay. So what's happening here? So I guess you may be familiar with the extends. You know, so class A extends B. You know, implements C. So that's class A implements. Extends B. B is the parent class, and implements C. C is an interface. You know, so you're familiar with all that stuff from your Java already. Okay, so here we use in C# we use this colon syntax to specify that the base, or the derived class inherits from the base. Okay, so we have a base class here. You could think of this as the parent class if you wish, and then we have a derived class or a subclass, and that inherits from base, or it's derived, and I like the phrase derived from, you know, in addition to you know, parent class or subclassing and so forth. But you know, it's the subclass as well, and we use this colon notation. So I mean, I've created this little note here so you can see the key piece of where it's happening. So let's have a look at the what's in the base class. Okay, so now this particular example has no methods at all. Okay, just deals with instance variables and the access associated with those instance variables, and you don't have to worry about the methods. The same rules apply to the methods as well. Okay. So yeah, before we go there, I just need to take one quick break. Give me 1 second. Sorry. Okay, I'm back. Sorry, thank you for that. Okay, so let's look at class base. Okay, it's the parent class, it's the base class. It has a publicly accessible string called myPublic. It has a protected int called myProtected, and has a private boolean called myPrivate. We set the variable values for these. You know, we could have created a constructor. We could have done all this work, and the constructor would be just base, with no parameters, or with parameters, and we could have done all that, but I'm just trying to keep it simple and not worry too much about methods and so forth. Okay, here's the subclass, and we can see that in the subclass, you know, we have a method called info, and that gives us, you know, the information in the derived class. So we should be able to write to the console my public and my protected, but we should not be able to write my private. So again, because of the encapsulations that's happened here. So this is private to this particular class, and that's just the way. It doesn't matter if you've got subclasses, they're not going to get access to this. And you could have getter and setters, of course, that would do that, or have some properties that would allow that and control those properties. You may have some protected one, but we know that protected means that it's available within this class base and also within the derived classes. So we should be able to see it. And of course, the public, that's available from everywhere. And really, public is just about the interfaces. And really, I tend not to like doing things, making things available unless they really are public and it's necessary. Okay, so again, as I said, we're using instance variables here, but everything that we've done applies to methods also. So let's head over to VS Code and see, can we see this one? Okay, let's go to the terminal. I can't remember what I said that one was called. Okay, probably my derived. So let's. Okay, so here we are in my derived. So this is my example here. Okay, so let's have a look at this. Again, it's no different to the example that we had in the actual lecture slide. So the base class is here, nothing has changed. It's really nice using VS Code because it gives us this kind of information, like the references, when they're used. There's no reference to this particular one here, so why is it here? Well, we know it's here, that we have 0 references and expect that because, we can't access it in the example. That's why it's commented out here. So if we run the app, okay, it tells us, of course, that information that, it's assigned a value, hasn't been used, but this is the derived subclass, the base parent class, and 100. So that's fine. So it's pulling these data not from the derived class, from the base class. And you may start thinking to yourself, well, what happens if I actually create something in here called my public in this class? That's where we're going to in a few minutes, okay? So let's have a look at this just to verify for ourselves. We'll see that we are actually referencing this here, so that's really good. But of course, it's going to cause us an error, and it tells us here. We know we're going to have a problem because it's telling us, that the issue here is going to be that we can't access this. We would expect that. Let's save this, and let's run it again, and expect that error. Okay, that's inaccessible due to its protection level. Okay. And that's what we wanted to see. And sometimes it's important that we include information in our code that will generate some errors for us, and that we understand the error. And I always think I don't ever have a problem with having errors as long as I expect the error to happen. And then sometimes we may want to generate an error. So because these are errors that users might make, and then we can trap that error and see the error that's going to happen, and then we can put it inside a try catch finally block or something, and then catch it and deal with the error in a graceful way. So sometimes we have to actually, set up our code to generate errors so that we can test. Okay, so not wrong with that. Okay, let's go back. So that's our inheritance setup. Okay, now there's a lot more to inheritance, and the short lessons, I'll probably go into these in a little bit more detail. Okay. If anybody has any questions around inheritance, they can just post a question to the chat, and I'll do my best to answer, or I'll just proceed with the next one. Okay, I think we're okay. Yeah. Okay, we move on to the next one. Okay. 2 more. Okay. Okay, so this one is polymorphism, and again, you know, I'm moving pretty quickly through these because I know you know a lot of this stuff, and we just want to see how it works with C#. But you know, it may be a while since you've used or thought about the terms. Okay, so polymorphism, again, we'll have a very simple C# example, and polymorphism means many forms. Okay, and it occurs when we have many classes that are related to each other by inheritance. Actually, the W3 Schools website has a really nice example of polymorphism in practice. And what I liked about that polymorphism example there, and I'd recommend you go there and look at the C# example, is that, as I mentioned earlier, it actually provides you with a real context and then the software implementation. Okay? So, you know, it gives a real world example of polymorphism and then shows you how to derive the code from this. And this is you know, a simple, very short, succinct, but perfectly correct example of how the polymorphism works. Okay, it's a bit shy in technical details in a way, you know, but you can fill in those blanks yourself, you know, and I'll go into that again a little bit later in one of the short lessons. Okay, so I took the program. It dealt with dogs and pigs and things, so, but you know, I mean, it didn't have anything related to cats, so, you know, I decided it would be a good idea to change it slightly and deal with a cat. But anyway, so really, again, I have a demo example code here, and so we can see how this works. So this last piece refers to the code here and the question I suppose I will ask a little bit here. So now let's start with an animal. So we're creating this animal class here, and we're saying that this has a method called animal sound, and it makes this sound because animals tend to make sounds, let's say. Okay, and I see a small error here in the code. Okay, let me just go up, but there should be a chain bracket here. Okay, close this class here. So we have this animal class and it has a method. So that method then we will override when we create an instance of that. So we're going to subclass this. Look, this isn't the best class design, no, but the example was good. Okay. So we have and we can see how we might improve it a little bit later. So let's create a cat, which is an animal, and then we're going to override the method and say that this cat says meow. Then let me just I prefer it to look okay. Okay, so now we have our things, okay? And so this cat says we have a dog which also inherits from animal, and we're overriding the dog animal sound method and say the dog says woof. So really what's happening here in terms of the different forms of the animal sound method, even though these both are inherited from the animal class, the base class, these derived classes each provide their overriding method for that sound, so that when they're instantiated, then they call this method rather than the base method. Okay, hope that's clear. So we see a lot of that happening in further lectures as well. So let's go to Visual Studio Code. Okay, so so I created one called my poly here, so we can have a look at that one. Let's go to Zen mode again here. So anyway, so we have our animal class, cat class, dog class, and our program. And this is the bit, I guess, that we didn't include on the slides. Okay. So what's happening here is we create an animal, which is just an animal, and it's create an animal object. Now, this kind of thing bugs me, you know, because, you know, there is no animal. really. When we look at animals, we're looking at instances of them. We decide that that's an animal or that's a building or something. We force and impose this structure on the world around us, the world we interact with. We impose these hierarchies, these structures, all that stuff. But you can say, well, that's an animal. Well, what makes it an animal? Because we have some rules in our mind that tells us that that's what that class is, or well, that actually is a mammal and that's a reptile. So we have all sorts of thoughts around this, but you don't actually see an animal that isn't some instance of what we consider to be an animal. Okay, so you could think about this, in a kind of a theoretical or philosophical way, if you like. But I don't like this at all. I would prefer if we weren't able to instantiate animals at all. So this is why we have something called abstract classes that we see a little bit later. Okay, but for now it's okay. Where I'm okay with seeing, well, that's a cat because it conforms to all the things we like to see about a cat or know about a cat, and that's a dog and it conforms to all the things we like to see about a dog, even though that dog doesn't look like the other dog, so it's fine. Anyway, we can do fun things here with this. Okay, so really what we've done, and the reason we're looking at it is just to show the overridden methods been called. Okay, so we've my animal sound, my cat animal sound, and my dog animal sound, and what we expect is that the first one will just give us the animal makes a sound, and then the cat says meow and the dog says woof, and this is the kind of thing we would expect to see happening. Okay, that's okay. Oh, sorry. Why is that? Okay, because I made a mistake. Why did I do that? Why did it do that? Create a new object. Did I make changes to the methods or something? Oh yeah, I know why. Sorry. Yeah, we did look at the count. Okay, so we look and say, well, why did this happen? Okay. Because for the dog, we got the animal makes a sound. And that's, of course, because I had made some changes to this particular program, for you, okay? Yeah, so you can see what's happening is that I took out the public override void animal sound, and I just said public void animal sound, okay? So there was no override in here. Whereas with the cat, I overrode the original method here, animal sound, okay? And so this was interesting, and this was fully expected. So we can change this back again now, and we'll do this. Okay. And so now we have an overridden animal sound for dog. Dog should say woof. I don't know if I saved it, but you will see. I did. Okay, so it makes woof. So we can do all sorts of fun things with these just to check the access, to check the instance, so look at the context. So, and where did I? Yeah, we can, yeah, that's fine. That's absolutely fine. I think that works okay. It works as expected. There's more complexities around this. Let's say we generate a class and then we cast to a dog, an animal, and we cast to a cat, or we do that kind of stuff. Well, we'll see a little bit later. Okay, so we're nearly finished. So I'll move on then, if that's okay, to the final one in this, and I've alluded to it already, which is abstraction. And I mentioned that, I really love the use of abstract classes because, they tell us a bit about, the rules, if you like, that we have for creating derived or based classes like animals, or, but it's, we often say that we might have an app, or we're generating an app that needs to run under Android, or we have an app that needs to run under iOS or under Windows. And you might say, well, we need to create this degree of functionality. We set up an abstract classes to describe how that context works, and then we implement the functionality that's specific for each operating system. They're all apps, but one might be to generate a Windows app, generate an iOS app, generate an Android app. So there's abstraction is really, really important for us in terms of reusing code and understanding how all the objects talk to each other. So again, we can see how abstraction works with a simple example. And these can all be done with simple examples. And the reason I'm giving you simple examples and not complicated examples, and it should fit within a few lines, is because I'm conscious that you're going to be interviewed for these things, and you need to understand these methods and understand what's happening here in these concepts. And I want you to be able to have something that's easy to remember and be able to work with this. So unapologetically giving you simple things, but we can make it complex if you wish. Okay. So data abstraction then is the process of hiding certain details and showing only essential information to the user. We saw that before, and it's really, really important. And we use the abstract keyword for classes and methods. So an abstract class is a restricted class that can't be used to create objects. In other words, if we had an animal class and we said an abstract class animal, we couldn't create animal objects, but we could extend that class and create a derived class called cat, and then we could instantiate cat objects. And it kind of fits better with our model of the world, or our model of the programming world that we're using. Okay, so basically, same thing happens with methods. Then an abstract method can only be used in an abstract class, doesn't have a body, and the body is provided by the derived class. It must provide the derived class. So you could say, what's an abstract class, or you can refer to this one, or you can refer to it in terms of its methods. But the main point is that you should know is that an abstract class can have both abstract and regular methods. You don't just have to have abstract methods. So you can call the method that's not an abstract method as well. So it's really important that you understand this. So let's have a look. So we'll create an abstract class by sticking the keyword abstract in front of class. So the abstract method then here is included as well in this particular example. So we have the class, and now we're making a public abstract void animal sound. So this is different from the previous example where we actually had our public virtual void animal sound method here, and we gave the functionality. But in here, we are just interested in saying, well, animals make sounds, so it's up to the derived classes to implement this. And if they don't, we'll complain and make an error, okay? So let's have our derived class, our subclass, class cat. Again, it's an animal. And so we're overriding this animal sound by giving explicitly what that method is, okay? And for the last time, we'll head over to Visual Studio Code and have a look at this. And I've probably unimaginatively called it something like, I don't know what I call it, my abstract, maybe. Yeah, my abstract. Okay, my abstract. So we'll just do this. Okay, and here we are in our application that we use my abstract. Okay, so we have our abstract class animal. Okay, it has an abstract method here. Okay, now we could put in regular methods as well, and we could call those regular methods. Maybe we might do that just before the end of the lecture. Okay, so we have a derived class animal, and it overrides the animal sound. And again, it's keywords here, our public override void, the animal sound. And there's nothing about any abstraction here. This is an abstract class. But we could probably make cat an abstract class as well, and then we might have to have another one say, public class domestic cat, is a cat, and then say something about that, and then have different kinds of methods there as well. So we can chain all of these things, and we'll see that maybe a little bit later. So, okay, let's go to our core program. We'll create an instance of a cat object, okay, and then we'll call that cat sound. So we're essentially calling not so much the abstract method, but we're calling, our methods realization of that particular method. Okay. Okay, so not surprisingly, the cat says meow, and we could put in another method in here. Let's make it public. And we just put a method here called sleeping, and it's public void. It's not abstract. You can see it doesn't have an abstract. That means that we should be able to call it from within the cat that we use down here. So we can say, let's this keyboard is not great. Okay, so now we can call this method, which is just a regular method within the abstract class. And we can see that this worked, and we end up calling this particular method. So you can mix your abstract methods and your regular methods, even in an abstract class. Okay, let's go back to this. Okay, that's it, I think. Yeah. So thank you very much for watching. Today we learned about object-oriented fundamentals using C#, and I hope it reviewed some of that material for you. Maybe you learned something new, this should be available, the stream should be available for reviewing, and I'll try to get those lessons as quick as I can at the moment. It's a bit tough going, trying to get them all done in time, and then I'm not happy with them sometimes, and I'm trying to reduce them down to 10 minutes, and I want to give you code as well, so that you can actually practice yourselves. So sometimes if you're trying to do a good job or think you're doing a good job, then it takes a little bit longer, but I hope the work is progressing well for you. Okay, thanks again, and thanks for attending the stream, and I'll see you all next week. You do know you can mail me if you wish. If you have any questions, we can always have individual team meetings if you like. If you are on campus and you wanted to have kind of a distance chat or something face to face, all masked up, we can do that as well. There's no problem too. But don't feel isolated in some respects. You can come and talk, and then be proactive, please. Okay, and I hope you're all well, and thanks for coming. Take care.